Here is the text from the photo. Engineering notes, structural design concepts. Functional design usually done by an architect. Structural engineer must work within the constraints imposed by this design. The architect decides how the building should look. The engineer must make sure that it doesn't fall down. The first priority of structural engineering is safety. Truss design. In this course, right arrow design of individual steel members, design of their connections. Figure shows a truss. Assumptions of pinned connections. Loads applied only at the joints. Each member will be a two-force member. Top chord, right arrow in compression. Bottom chord, right arrow in tension. Web, right arrow in com. Frame design. Figure shows a rigid frame. Members are rigidly connected by welding. Can be assumed to form a continuous structure. At the support, right arrow members are welded to a rectangular plate. Plate is bolted to a concrete footing. Frame can be treated as two-dimensional. Members can be represented by their centerline. Right arrow support represented as hinges, beams. Right arrow deformations are very small. Load types. All live load in this course will be treated as static. Dead loads are called gravity load. Dead load impermanent in nature. Live load often treated as separate categories. Here's the text and figures from the photo. Mechanics and steel sections where F equals axial tensile stress, A equals cross-sectional area, epsilon equals axial strain, L equals length of specimen, delta L equals change in length. A small diagram showing a specimen of length L subjected to a tensile force P with the resulting elongation delta L and cross-sectional area A. Proportional limit, elastic limit, upper yield point, lower yield point, ultimate tensile strength F_U, yield strength F_Y, elastic region, plastic region, necking region, residual strain E, where epsilon equals elongation, L_F equals length of specimen, L_0 equals original length. Different grades of structural steel are identified by the American Society for Testing and Materials, ASTM. Mild steel is designed as ASTM A36. Cold formed steel is created by bending thin materials such as steel sheet. Advantage, right arrow almost any conceivable shape, increase of yield point. Disadvantage, right arrow reduction in ductility, problem of instability. W shape with cover plates, I-beam with top and bottom plates, plate girders, deep I section formed from 3 plates, double angle, 2 L sections connected back to back, double channel, 2 C sections connected back to back, forming a box or H shape,